Okay, some context questions, or just questions worded a little bit differently, which I thought were worth looking at, you know. So again, feel free to read these questions, have a think. But the very first part, when you see this, you should be thinking to yourself, wave function. Okay, so I'm going to put it up here, wave function. So the first thing we do is we do our expansion. So I've got k cos x cos alpha, and the signs change. So I'm just breaking out this bracket here, and then I'm going to rewrite it. And all I've done here is I've moved the sine alpha to the front and the cos alpha to the front, and that's so that I can now equate on the next line. Okay, I've not moved about the x's and the alphas, I've not switched the x and the alpha. Okay, I've moved this in the same way that if it was a sine x cos x or sine x cos alpha, I'd move the cos alpha to the front. So you want your cos alphas and sine alphas on the front. And to do this next bit, I'm just going to have to write my question. So it was 5 cos x take away 2 sine x. So again, quite a nice one. You'll see most of them don't require a change of sign actually, which is good. I have got one of those examples in. So the cos's equal to each other, the negatives equal to each other, the sines equal to each other. Therefore, these have to equal each other and these have to equal each other. Next thing I'll be doing is working out my alpha. So to do that, I'm going to say, well, I know that k sine alpha is equal to 2, and I know that k cos alpha. Oh, sorry, my handwriting's getting worse and worse and worse. I still haven't really got the hang of this pen yet, have I? I mean, this has been thousands of man hours on this, and I'm still a bit rubbish at this. But anyway, 5. So that means that tan alpha has to equal sine over cos, which is 2 over 5. So if I do inverse tan of 2 over 5, now this is in radians. Okay, so you get some radians. So make sure your calculator is set to radians. So shift mode, and then radians is 4 for me. So shift tan, or inverse tan, 2 divided by 5. So that's 0.38, and I'll call it 1. 3 decimal places for your radians is about right. For degrees is 1 decimal place, I think, but 3 for this. Don't do 1 decimal place, you're pretty far off. Okay, so 3 decimal places. And I'll just quickly double check on my CAS diagram if I have to do anything. We should know by now that I don't, because sine is positive, cos is positive, tan is positive. So where is sine positive? Where's cos positive? And where's tan positive? So I'm in the first sector, so it's just x, so that's fine. Next thing I'm going to do, work out my k. And this is like your kind of Pythagorean kind of calculation almost. So k is 2 squared plus 5 squared square root. Looks like Pythagoras, doesn't it? But it's just because if I was to square this and this, I'd be left with k squared, which is why I square root this to get k on its own. And squaring these, sine squared and cos squared give you 1. So it cancels out. You take out a common factor, but we don't have to show any of that. We just have to do a calculation. So 25 and 4 gives us root 29. So if I write this wave function out, final answer, the wave, let's see, root 29, and that was a cos transformation, and it's x plus 0.381. So what this means is I can rewrite 5 cos waves taking away 2 sine waves as a single cos wave. We've discussed that in, I think it was video 1. I showed you that, but yeah, this is our combination of these two waves. Now, the next question. The diagram here shows this graph, so it's the 5 cos take away 2 sine, but 10's been added. Okay, so similar wave to what we've got, but we've added 10. And the line y equals 12. Find the x coordinates of P and Q. Okay, so P and Q occur when y is 12, that's worth noting. What's their x value? So let me just draw that on, that's 12. And I'm saying, where is that function equal to 12? Okay, so it's really asking, when is this function equal to 12? So 12 is equal to 10 plus 5 cos x take away 2 sine x. So when does this function here equal 12? Fair enough. If I was to rearrange, I'd be in a sticky situation because I have cos and sine there. However, I can unstick myself because I know that this I've already worked out is the wave function. So that is root 29 cos of x plus 0.381. And that's what most of these questions get you to do, is to equate the wave function to the original function. Yeah. Now I can start to rearrange this, can't I? So I take away 10 from both sides. So I've got 2 and divide by root 29 to be left with cos of x plus 0.381. Yeah. So take away 10, divide by root 29. Fantastic. So I'll do the inverse cos of that. So inverse cos, shift cos, 2 divided by root 29. So that comes out as 1.19, and that's then equal to my x plus 0.381. Next thing I've got to do is my cast diagram. So I'm looking for when is my cos function positive, because this value here is positive, that's when I did my inverse. So it's positive here and here. So in quadrant 1, my answer is simply just 1.19 is equal to x plus 0.381. That's fine. But in quadrant 4, my answer is 2 pi take away 1.19 because it's in radians is equal to x plus 0.381. Very good, x there. Yeah. So the first one, 1.19 take away 0.381. So this gives me 0.809 radians. And this one, my x is going to come out as, so 2 pi, 2 times pi, 2 times pi, take away 1.19, and then take away 0.381, so that comes out as 4.712. So what that means is, that and that are my two x values for here and here. And I think I would maybe just write that down as a final solution, final answer. Maybe just say then that 0.80912, there's a coordinate, that might be my coordinate P, that's coordinate P, and my coordinate Q is going to occur at 4.712, also 12. Excellent question. I think that bit might have thrown a few people because there's a lot going on here. Why towards all that mean? And I think this is where, if you watch the earlier videos, having that, seeing the Desmos and having to think about what you're actually doing, this question is not very scary. But if you just go through the motions early on, you might think, well, what am I actually doing? So yeah, taking this function, setting that function equal to 12. When is this function equal to 12? That's what I'm trying to solve. But we can sub out this bit of the function for your wave function and then just rearrange. Okay? Usually what they've been asking for is when is this function at a maximum? So here you're saying, well, what's the maximum? Well, I know the maximum of my wave function is root 29. So the maximum will be root 29 plus 10. So yeah, just get used to trying to visualize it, and it really help. And I hope that recipe now for the wave function is starting to come through. Break out your given your addition formulae. Make sure if you've got a plus for the cos, you change the sign. Don't forget that. Everything should look the same. Do your alpha, do your k, final answer. So some great marks there. 8 marks. That took me less than 10 minutes, and I've been chatting away. So I know you might have had to think about that a wee bit in the exam, but still, for 10 minutes for 8 marks, that's really, really good. There's a lot more algebra and manipulation and some of the other questions, and for this it can be, I'm hoping you're seeing that now, quite repetitive and formulaic. So I think logs and exponentials, wave function, excellent marks to be had, because it's applying it's almost quite a strict recipe, isn't it? So definitely keep going through these. We'll do this on the next video.